Before we look at more data for the Vulture studies, let's establish a baseline framework for how scientists measure toxicity. In ecotoxicology, or ecotox, or ecotoxicology, or environmental toxicology, we use a method called the dose-response analysis to quantify exactly how toxic a substance is. In this method measures the strength of a toxicant's effects, or simply the number of individuals affected at various exposure levels. When conducting these tests, the dose is the precise amount of the chemical or toxin or toxicant the animal or test subjects receives, and we plot this on the horizontal x-axis. The response is the type or magnitude of the response or effect that we see, and this is plotted on the vertical axis. When you graph these two variables against each other, you get a dose-response curve. Typically, nothing happens until you hit a certain threshold, in some cases. But as the dose increases past a threshold point, the negative effects begin to climb. The most critical metric we look at in this curve is the LD50, or the lethal dose 50. This is the amount of toxicant it will take to kill 50% of the test subjects. Keep this framework in mind as we pivot back to our vultures and look at the specific dose-response curve from one of the vulture studies. As you saw from the table, diclofenac is toxic, incredibly toxic, killing a massive percentage of the vultures tested, while meloxicam proved to be non-toxic to vultures. Take a look at this graph, the graph on this slide, focusing on the thick curved line. The x-axis shows the dose of diclofenac administered in milligrams per kilogram of body weight, and the y-axis shows the proportion of vultures killed. If you need the long description for this image, please see the notes for this slide in the PowerPoint. Pause this video one last time and analyze the dose-response curve. What is the approximate LD50 for diclofenac in vultures? Submit your answer in the platform provided by the instructor.